Good afternoon or good morning if you're on the other side of the ocean from me. I'm going to start us with our webinar for INAT, International Network on Appropriate Technology. And today we have Professor John Tharakan, who is a professor at Howard University, who will be speaking on appropriate technologies for water and sanitation. I'll turn it over to you, John.
Thank you very much, John Trimble, for that brief introduction. My name is John Tharakan. I'm a professor of chemical engineering at Howard University in Washington, D.C., and I will be speaking about appropriate technologies for water and sanitation, just providing a general introduction and critique. By way of introduction, I'm also a visiting professor at a College of Engineering and Technology in Kerala, India, where I work with a group with the Graduate Environmental Engineering Program. I'm also the faculty advisor for Engineers Without Borders, the Howard University chapter of that organization. And we conduct water projects. We are currently engaged in a water project in Kenya, and we have done others in Kenya and Senegal, as well as in Panama and Brazil. I also spent a couple of years in India as a Fulbright scholar, first at the New College in Chennai, where we talked about biological technologies for waste transformation. And then later, about 9 years ago, at the Cochin University of Science and Technology, where we were looking at the impact of novel technology implementation. So in this, briefly again, I'm at Howard. Howard is a historically Black college and university located in Washington, D.C., in the capital of the U.S. We have about 12,000 students, about 11 schools and colleges, and I am in the College of Engineering and Architecture in the Department of Chemical Engineering. So to begin our look at water and appropriate technologies for water, I want to start with this slide here where you can actually drink the tap water, that is the water that comes out of the tap. This is a map of the globe, and as you can see, there are very few countries, and the population that is covered by those blue colors is fairly small. That's about less than 20% of the world's population that has access to drinking water from the tap. More recently, those of you who might have been following the news know that this blue map over North America is not entirely blue. There are localized spots in Detroit and in Native American reservations and in other small communities where you cannot drink the tap water. So this is a misrepresentation. But in general, in the developed countries of the global north, you can drink the water. But if you look at the global south, you cannot drink the tap water. You really need to put it through some other filtration mechanisms in order for it to be made potable. And this is more than 80% of the world's population. So if you look at this red zone, the state of life for many of these folk is not as comfortable as it is for us in the West or in the global North. Close to 1 billion people live without reliable access to clean, safe, and potable water. Almost 2.5 billion people have no adequate sanitation, and almost 100 million children are underweight. There are 1.6 billion who lack access to adequate safe housing and shelter. 1 in 6 have no access to electricity. 1 in 4 have no access to the internet. So there is a great deal of inequity that we see, and there is a great need for development and appropriate technologies. In the water and sanitation context, 1 out of 8 people lack access to potable water. And there are millions of people who die every year because of waterborne health issues. And as we said before, sanitation is not available to everybody. And in terms of the development that has happened, development agencies have been installing hand pumps across the global south for the past 20, 30 years. And of the about almost 1 million water points that were installed in sub-Saharan Africa, about 30% failed prematurely. And just in one country like Ghana, almost 60% of the water points that were installed need repair. So there's non-existent and broken sanitation throughout the developing world. And if you look even in emerging countries and economies like India, which, is one of the fourth largest economy in the world, 13%, only 13% of sewage sanitation is actually treated. Well, it's obviously increasing a little bit, but the pace at which this progress is going on is very slow. So in this webinar, what I'm going to do is talk a little bit about how we got here, discuss appropriate technology from the perspective of what are some of the criteria that characterize appropriate technologies, what are the rationales for their implementation, and then focus in on appropriate technologies for water. This webinar was supposed to be on water and sanitation, but once I went through most of the background and slides that I wanted to present on water, what I decided was that we are going to have another webinar sometime later in this series that will focus on sanitation. And in this webinar, I'm going to focus mostly on appropriate technology and water. So how did we get here? Well, here's a map showing the countries that Britain has not invaded over the past 400 years. So clearly, if you have some understanding of history and what has happened over the past 400 to 500 years of colonialism and imperialism, we have witnessed the plunder of the developing world. We have witnessed resource extraction and transfer on a huge scale. And the technology transfer that was put in place from the global north to the global south was mostly focused on technologies that would enable resource extraction and transport to the global north for its use. So as a result, over these past centuries, the net transfer of wealth has been from the global south to the global north. The net transfer of resources has been from the global south to the global north. And that has resulted in the state that we see represented in this slide, where so many people lack access to the very basic qualities and necessities for making life livable. So once again, focusing now on the development in technology that occurred over the past century, once colonialism ended, that development was still very top-down. Those were interventions that focused on the transfer of technologies that would enable resource extraction. There was insufficient investment in human capital development. There was virtually no investment in building the capacity of communities on the ground. And certainly in terms of these water pumps, for instance, they didn't do any training in terms of operation and maintenance so that the technologies that were put in place to improve the qualities of life would actually sustain and be able to perform the functions that they were supposed to do. So this has all resulted in the development paradigm that has been adopted, for the past 200 or 300 years with the modern scientific knowledge of the global north, represented by this white man in a white lab coat, telling this brown man in the global south what he or she needs to do in order to live a good quality of life. This is not appropriate. What it does is it marginalizes and devalues indigenous knowledge systems. It dismisses the knowledge and values and experience that the local communities have, and essentially results in undevelopment. So the development paradigm that we operate under is essentially the development divide that we are seeing. So in this steps in appropriate technology. And some of the criteria that we use to characterize appropriate technologies that it only requires small amounts of capital. It emphasizes the use of locally available materials. It tends to be labor intensive, not capital intensive, tends to be small scale, so it's affordable to individual families. And the technology can be understood and controlled and maintained by individuals without necessarily high levels of education or training. It can be produced in small village shops, and it assumes that people will work together to improve communities. And it includes the local communities in the innovation, modification, development, and implementation of all those technologies. And it's very important to understand that AT is context specific. So it's not always the case that appropriate technology has to be small. And we've had this discussion before. And in terms of one of the appropriate technologies that might be considered a large scale appropriate technology is, say, a dam that might be constructed that will benefit a huge region of a space. So these are some of the criteria for determining whether a technology can be considered appropriate. Clearly, it's very context specific. And the rationale behind it is that it permits local needs to be met more effectively because local people are the ones who are basically identifying and addressing these needs. It represents activities that are controllable and comprehensible to the local communities. It permits more economical operation because it minimizes or eliminates transportation. And it basically helps establish self-sustaining and expanding reservoirs of skills within the community. So the fundamental rationale for AT is really empowering people on the ground to be able to take control of the resources and utilize the resources locally available to improve their quality of life. But with that sort of a background and introduction to appropriate technology, we can talk about appropriate technologies that have been developed and are being developed for water and for water use. So I'm going to talk about technologies for water collection. These include things like rainwater harvesting, different kinds of water and bore wells, as well as talking about reusing gray water. So we'll talk about some of those ideas under water collection. We also have to talk about storing the water that we collect and being able to move it around. So we'll talk about hand pumps and some appropriate technologies such as ferro cement tanks that have been developed and have been implemented for water storage. And then perhaps most importantly, we'll talk about water treatment because obviously it is the contaminants in water that lead to sickness and disease. And so it's very necessary to be able to treat water to make it potable for human use. So we'll talk about some of the appropriate technologies available for that. And we'll also focus a little bit on the other major use of water, which is for agriculture and some of the appropriate technologies that help reduce the use of large amounts of water in irrigation. So first, talking about rainwater harvesting. This is a fairly straightforward technology. We're talking about collecting water that is falling from the sky. And for this, what we need is a catchment area. And typically, the catchment area is the roof of a building. That is then, you can calculate the catchment area by the area of the roof. And if you multiply that by the annual rainfall, you would be able to calculate the potential volume of rainwater that you would be able to collect. And multiplying by that by the efficiency, you can actually figure out how much actual water you can collect. So you can figure out what this would mean in terms of your water needs from, say, the main source. So this illustrates in this diagram a complete system where the rainwater is harvested as it falls off the roof, is pumped into a storage tank, and then from the storage tank, it goes through a treatment process before it is pumped into the house for use. So that is how rainwater harvesting and collection might be implemented within, say, a house. And of course, this can be applied and implemented on buildings and other facilities that are being constructed. And it's important to understand that rainwater harvesting is one of the technologies that have been implemented worldwide to reduce the need for fresh water from bore wells and surface water. And in fact, in a number of municipalities, now it has become the law that if you construct a new building, you have to construct the building with rainwater harvesting technology built into it and in place before the building is put into service. And in fact, they have laws where old houses have to be retrofitted with that kind of technology. This is a water treatment, a very low-tech water treatment system. It's called the slow sand filter, and essentially what it is a big tank with sand, with a bed of sand that is supported by a shallow gravel bed to enable the flow. And raw water comes in from the top. It percolates through the sand, and basically that is the process of filtration, where you get clean water coming out of this sand filter. The quality of the water coming out of a sand filter is fairly high. In most cases, depending on the depth of the sand bed and the quality of the raw water that is being fed to the system. The outlet from this is sometimes potable, but occasionally it does need to be treated with further something like chlorination in order to get rid of the last remaining microbial contaminants. Here is another low-tech chlorination pot for use in a rural setting, where you can actually make the water here potable. All you need is bleach powder and sand. And with this low-tech assembly, you can actually get water that has been chlorinated and cleared of microbial contaminants. Another appropriate technology is to use solar energy. And this is a very simple solar still. And essentially what this is doing is it collects seawater that is then evaporated through the heat from the sun. The evaporating seawater, which is just water, then condenses on the glass surfaces, and then is collected, and that water is distilled water and can be basically drunken. It's clean enough to drink. So that is a very simple solar still that can be constructed out of plywood, mirrors, tubes, and pieces of glass. So very simple technologies that can be assembled in order to produce clean water from the sun's energy. Here is another. Irrigation is another technology or area where water is used extensively, and most of the water that's used actually doesn't serve its purpose. So when you do flood irrigation, which is uh, the most widely practiced type of irrigation in the world, essentially you're flooding the fields with water. And so a lot of the water that percolates through the plants and the root base doesn't actually get used by the plant, but continues on down into the water table. So about 60% of that irrigation water is not used. So one of the innovations that have been developed is something called drip irrigation. And drip irrigation is, from a technological perspective, is fairly simple. All you need is a bucket and a tube with openings. So you can see this very simple thing over here. Bucket has been set up with a tube with lateral uh, uh, outlets that essentially, and as the name implies, the water comes out fairly slowly. It comes out in drops, and it comes out directly into the root, so that the use of that water is almost completely used. So there you're not wasting any water on the when you use drip irrigation tech. So there are some larger versions of this, and even much larger versions that go across huge fields that have been put in place. Clearly, you need a little more material because you need this tubing and you need the pipes and so on to set drip irrigation up. So there is some investment, but the investment need not be very high cost, and so can be employed in a number of rural settings. This is a point of use technology. This is something that we have to figure out if they're actually necessary, whether they're appropriate. And so what you see here in this picture is one of these straws which have built-in filters so that you can basically dip this into any water source and suck up the water. And because of the filtration mechanisms that are built into this tube, essentially the water that comes out on the upside of the downside of the filter and into your mouth essentially is potable. And clearly, these are things that are necessary and probably quite appropriate when we're out hiking in the wilderness and so on. But it's not something that I think is something that we need to, make something that needs to be scaled up and distributed across the world. We should be getting clean water coming out of our taps. That's what we should be aiming for. Pure powder. This is another a chemical way of treating dirty water. So here you see the muddy raw water that has been put in place. And then you add this pure powder, and what that does is it essentially coagulates the contaminants that are in it and flocculates them together, and so that you can now filter that and entrap all of the contaminants so that you get potable water that comes out on top. Another solar water purification technology is simply putting the water in a clear plastic bottle out in the sun, and the solar rays essentially basically disinfect the water. So here you see a picture of water being disinfected in the Kibera slum in Nairobi. Clearly, this is not the most desirable solution, but in terms of addressing people's needs in a short term and for the near term, this is certainly an appropriate technology that can be implemented and used with fairly little training and fairly little technological investment. All you need are the clear plastic bottles and, of course, a way of filtering out some of the gross contaminants and then being able to put this in the sun. Clearly, you also need a sunny day because without the solar rays, the sterilization does not take place. The question, of course, is will appropriate technologies work? And one of the answers is it's a conditional answer. Yes, they will. But there are no predefined criteria for appropriateness. It's always going to be situation and context specific. The geography is going to matter. The culture of the population and the community that is being served is going to matter. Where this is located, whether we're talking about a rural community, whether we're talking about something, a slum community, whether we're talking about a community way up in the mountains or by the river, what are the resources that are available? So the context is very important in terms of determining whether something is appropriate. So you cannot determine the appropriateness of a technological implementation without considering what are the overall costs and benefits. Who is going to pay the price of the technology's implementation and who is going to benefit from the implementation of that technology. So there are many non-economic criteria that are going to play a role in that technological choice. And so we have to be careful whether, whether there are institutional prejudices that are going to influence the technology choice that we make. We have to be always focused on ensuring that the technology is appropriate for the community being served and that it actually leads to capacity building and empowerment on the ground. So one of the examples that I wanted to highlight that we, through our international network on appropriate technology, were able to experience a few years ago was the Songhai Center, which is located in Benin, and they run something called the Songhai Leadership Academy. One of the individuals in charge is Father Godfrey Zamujo, who's written extensively about development in the African context. And he wants to focus on redesigning African universities to make them knowledge enterprises that are committed to serving society. And the main focus of these universities have to be generating new knowledge that will enable social innovation and entrepreneurship. And the whole Songhai model is grounded in the concepts of agroecology and the circular economy, where production systems are integrated. So, for instance, crop production, livestock, aquaculture are all integrated and circular, resulting both in the production of goods and resources and the production of energy as well. So these integrated production systems essentially ensure that the development that occurs is sustainable, because we're not talking simply about growing resources and then exporting those resources. What Zamujo's focus is on primary production, as well as developing and implementing the technologies that will value add to the primary production, both in terms of food processing, manufacturing, and whether we're talking about crops, livestock, or fish. The community has to be integral to processing and value adding to the community's product and having marketing services that are able to support all of that. So this integrated system the Shanghai agroecological model is one of the models that we through our, we have come across that essentially brings together the community, it brings together the resources, and it brings together the businesses and the industries so that they all work in a networked, symbiotic as well as cooperative manner so that the synergies can be exploited. The synergies of bringing these things together can be exploited and developed. And the other thing that I want to stress on in terms of appropriate technology is indigenous knowledge. And if you go back to where I talked about the development paradigm and the development divide, where the man in the white lab coat is telling the farmer in the global south what to do and ignoring indigenous knowledge, that is a problem because that indigenous knowledge has been generated within the context of that culture and that society. And so it is quite different from, I mean, it is adapted to the conditions of that community, that geography, the sociology, and that climactic space. So when we talk about modern scientific knowledge, which is the basis of the man in the white coat telling people what to do, that comes from the modern scientific knowledge systems, which of course is knowledge from universities, research institutions, knowledge that comes through formal education and advanced study and training, and what we do in our labs. That's modern scientific knowledge. But that is quite different from indigenous knowledge, which, when you think about it, has no theoretical grounding, and it's constantly changing. It's being produced and reproduced, and it's being discovered and expanded as the community grows and develops. And it shares much more. It's shared more than modern scientific knowledge because of the intellectual property that confines and restrains the spread of scientific knowledge, of modern scientific knowledge. So now I'd like to focus a little bit on India, since that's where I happen to be from, and talk about water availability in India and some of the technologies, that the indigenous technologies that have been employed to make water available. So of course we have rainwater harvesting, has actually been practiced for centuries. It's not something that's new, but it has been practiced before. And there was harvesting techniques of many kinds that you've seen over here, harvesting from a from a watershed using a check dam, harvesting through service wells, harvesting water over an entire landscape. So in Tamil Nadu, there are along the entire landscape has eries or lakes, and these are at different elevations. So as the water falls on the hills and flows down, it fills those up, and basically those lakes get recharged, and the water gets stored through those eries for use during drier seasons. So those are some of the indigenous technologies. Here is another one. A naula is a surface water harvesting method, typical to one of the hill areas in Uttaranchal, which is a state in northern India. And essentially, they're small ponds in which water is collected by damming it, and that's used for drinking. We also have things called step wells. And you might have seen these step wells. Here's a schematic of an ordinary well, which is just a big hole that is drilled into the ground until you reach the water table. But in a step well, essentially the land and the geology and geography around the subterranean water pool are taken advantage of, and structures are built so that people can basically go down and access the water during the dry season. So there are some other examples of how this water is stored. So here is a cross-section cartoon through one of the forts in northern India, where you have the rainwater falling, being stored in underground cisterns or in underground wells or in step wells, as shown over here. So these are technologies that have been around for millennia. People have known about step wells and the need for harvesting water and saving water in the, for the dry season for ages, since people were experiencing wet and dry seasons. So we have to be cognizant of all of the appropriate and indigenous technologies that are available for use in water. So here is a dong, which is a system that's used in Assam and North Bengal, basically to use water for paddy cultivation, paddy which is rice and which uses a lot of water. And so they're sort of like canals, but they basically route the water to the paddy fields and facilitate cultivation of rice. Ahar pines is another indigenous technology. This is basically a catchment basin that they've embanked on three sides. And the fourth side is the natural gradient for the land itself. So that essentially you're storing this water for use in agricultural fields. And it's interesting to note that this technology, this indigenous technology, was actually destroyed by the British when they came in the 19th century, because they thought that it wasn't something that they could use. They wanted something different. But again, indigenous technologies can be used and can be drawn upon for water resources, and whether it's for drinking or irrigation. As seen here, this is again the Ahar pine irrigation structure that we see in some parts of India. So to wrap up, appropriate technology that integrates indigenous knowledge into sustainable technology development and implementation. If we do this, the chances of success, I think, are greater. Most of the development projects that have failed because the developing agency has usually failed to engage the community in its own in its own improvement. Basically, there are existing institutions already trying to solve the problems that development agencies think they're solving. We have to be very careful about making sure that the approach we take is equitable and that the technology is not just going to benefit the rich in the rural setting, that in fact it's going to benefit everybody. So we have to, in some way, be able to take advantage of this traditional native knowledge and integrate it into our understanding of modern scientific knowledge in order for us to implement appropriate technologies. So I will end with this final slide that basically contends that appropriate technology can be the bridge that we can focus on, that will facilitate the integration of modern scientific knowledge into communities and will empower communities through a validation of their indigenous knowledge systems and engaging their indigenous knowledge systems to in their own development and in improving the quality of their own lives. So I feel appropriate technology can be that bridge to do that. And with that, I will end and be happy to answer questions that the audience may have. Thank you. Thank you very much.
Thank you, Dr. John Tharakan. Now I want to open it up for questions. You can raise your hand, and I can then recognize, and we can entertain questions. And while people are doing that, I have a quick question for you. Um, I know that the COP in Brazil is now just ending, and there it was discerning that the number of the key players don't seem to be concerned about the fact that it's climate change. But can you say something about how this use of fossil fuels in particular, but how much of industry is impacting our access to clean water uh, by the contaminants that they are putting in the water and by even the processes that they're engaged in? Uh, Thank you.
Well, thank you for that question. I think one of the big tensions is going to be between the use of water for industry and for the growing, the data centers, which require a lot of water as well as energy. So there's going to be this tension between water use for communities and water use for industry, and I think that's something that we're going to have to be careful about and be always aware of, um, and uh, and focus on ensuring that the communities are prioritized in terms of water needs.
Thank you. And I see Myron has his hand up. Welcome, Myron. Please go ahead.
Greetings. Thank you, John, and with John and John. Pleasure to meet you, Dr. Tharakan. I'd actually recently sent you a LinkedIn invitation. I really would like to engage with you more deeply going forward. But I may, so a couple of things. One is that COP is not finished. It goes on for another week. And in fact, I'm about to leave home to get on a plane to go to Belém. I'll
Okay.
be attending the last week. And certainly the challenge of major players, those who have the financial and technological resources, are backing away from climate change. All the more reason for self-sufficiency, not just in the context of appropriate technology, but in the context of our being able to generate those technologies and make them our own.
Mhm.
Um, and I was really impressed, Dr. Tharakan, with your sort of idea about synthesis of indigenous knowledge and modern scientific knowledge.
Mhm.
That's a real challenge in a lot of contexts, and I'm working both with African American communities and African communities. In particular, in the African American context, there's the desire sometimes to completely reject Western technologies
Yeah.
and throwing out the baby with the bathwater as a consequence.
Mhm.
One thing, my own background is in molecular genetics. I believe in the promise of biotechnology and GMOs for community benefit, but often well-meaning people say nothing with GMOs, um, and again throwing out the baby with the bathwater. I accept that, and I've been trying to argue that the problem is not the technology; it's ownership of the technology,
Mhm.
and would like to be able to encourage people as the technology becomes more accessible. Want people to be able to actually use them to develop things that respond to their needs.
Mhm.
So yeah, that dichotomy, that challenge, how to get people to integrate, wanting to go back to nature, as it were,
Mhm.
and use traditional knowledge. But I think the important challenge is to blend our modern scientific understanding, which has been very powerful. It's just been used for profit, for the benefit of the few rather than the many.
Mhm.
And I imagine there's some theoretical framework for that. But if you have any thoughts about how examples of encouraging that use of modern understanding together with traditional approaches and methods that have blended well. That would be valuable. So thank you.
Okay, well, thank you, Myron, for that comment and question. I certainly am with you when, their biotechnology has a lot to offer. And I think we have to be, but at the same time, genetically modified organisms being released into the wild, we have to be careful about that. So there are, I think, contexts and systems where GMOs are actually going to be necessary. So, for instance, when we're talking about producing insulin with a genetically engineered yeast, that is great. We're producing a valuable product. The genetic engineering of the yeast is clearly appropriate and needed, and it is contained. So in that, it works very well. But then if you're talking about having a GMO being released out into the wild without sufficient controls, then there are some issues with that. So I think it's important for us to be very careful and aware of what exactly the technology is and what exactly it is impacting and producing, and be careful about not sort of blanketly, saying, okay, just because it's genetically engineered, it cannot be used. I mean, I think the application and the context within which a technology gets employed and developed is very important, and can be determining in terms of the impact, whether it is positive or negative in the long term. I hope that sort of addressed some of the issues you were asking about.
Yes, I mean, and again, I think the question of the mechanism for that evaluation, and then ultimately sort of community dissemination of expert and traditional, and a synthesis of those two effectively. But yeah, thank you.
Yeah.
And I agree.
Thank you.
Thank you, Myron. And I'm glad you pointed out that there's still more to go with COP, and we definitely want to get you on board to do a webinar when you get back to report on it and give us some ideas of the way forward. I see Gada has her hand up. Go right ahead, Gada.
Thank you, John, and thank you, Tharakan, for this talk. I want to come from the critique about. I mean, my question is related to this critique of appropriate technologies being seen as inferior, and also your in your talk where you talked about how appropriate technology could be the bridge between modern scientific knowledge and indigenous knowledge. So I was wondering, I mean, one of the ways in my head about this would be to be able to do monitoring, for example, of how the water amounts that are being saved with the different types of technologies, whether they are from the local knowledge or whether they are from the modern science models, or have some real-time monitoring about that. And also things like when you talk about clean water, how these can, where the evidence that once that local I mean that appropriate technology is implemented, is how can people also be able to generate evidence of how clean that water is. But on the other hand, of course, that complicates the technology itself. So there is some trade-off there, because you at the end of the day also want that this technology be simple enough that that as much as possible be developed from local material, and also train local people to be able to maintain and run it. So there is these kind of trade-offs there. So I don't know if you have some comment about that.
Thank you, Gara, for that question and comment. Well, I think one of the key failures for development has been the lack of knowledge transfer that should accompany any tech transfer. So that is, and that is a big problem. And the way, for instance, we address it as when we do an Engineers Without Borders project, say in a community, and we were, one of the projects we had was building biosand filters in the community and placing them in various houses and institutions in that community, such as the school and the clinic. When we did that, we also spent a day where we did something where we trained what we called as community engineers, sort of similar or analogous, if you will, to Bunker Roy and his barefoot solar engineers. The concept, the idea there is making sure that members of the community are able to basically maintain, control, and operate any technology. And that knowledge transfer has to accompany any tech transfer that takes place. I don't know if that addressed what you were thinking about.
Yeah, it addresses it partially. Thank you.
Okay.
But I was thinking about embedding other technologies with the appropriate one that you've selected, whether it's sand filters, whether it's those water harvesting that actually monitors whether the amounts, or monitors the cleanliness, or monitor the purity of the water. Those other kinds of more
Right.
sophisticated, but again, that would kind of beat the bit that you want to make it as simple as possible, but to make appropriate technology to make that bridge happen. Something has to happen between these two worlds.
Right. And I think that the thing that has to happen is that knowledge transfer and that sharing, where you actually bring those people together so that they understand where each other is coming from and what each can bring to the table for the project at hand.
Thank you, Gada. Thank you, John, for the response. So again, thank you, Dr. Tharakan, and thank you for our participants from INAT today and from outside. And if there's anyone on that's not a member of INAT, please go to our website and check it out and become a member. Thank you again. Enjoy the rest of your day.